Right, Bismillahirrahmanirrahim. Assalamualaikum and a very good afternoon. So today we will continue our dynamics class with a new chapter. Before that, I have already finished marking test 1. So macam mana you rasa, susah ke senang test 1? Susah. So on average, I think saya tak berapa happy sangat dengan markah you, tapi it's okay. Average, you on average you dapat half of the mark lah. Maksudnya kalau kita calculate average untuk semua student, the average is 7.5 out of 15%. Okay, soalan yang paling bagus ialah question 1. Many of you got full marks for question 1. Very good. Question 2, tak ramai sangat dapat full mark. Question 2 ada, on average pun markah dia ialah 5.7. So most of you dapat separuh markah lah untuk question 2. Dan question 3 yang paling teruk, tak ada orang pun dapat full mark question 3. And average mark is 7 out of 20. So I'm not sure why. Question 3 I think it's not that difficult, tapi ada ramai juga yang tak berjaya untuk lukis free body diagram dengan betul. So that is very sangat rugilah, because free body diagram alone provides 6 mark for question number 3. So kalau you dapat lukis free body diagram dengan betul, you dah dapat 6 markah lah for question number 3. But never mind, I'm still compiling all the marks for test and also quiz. I will release the mark by Wednesday, and you will be able to see in your ecom account all the marks for quiz 1, quiz 2 and test 1. Quiz 3 saya belum settle lagi. Okay. So let's just continue with our class for today. Today we are going into a new chapter. Okay, we have until now finished 2 chapters of dynamics. Chapter 1 was kinematics, okay, where we discuss about the characteristics of motion. Okay, we discuss about displacement, velocity, acceleration. So these are the characteristics of motion without actually looking at the forces that causes the motion. So every object in motion, setiap objek yang bergerak mesti ada force yang bertindak pada dia, tapi dalam chapter 1 we did not discuss about the force. Then we go into chapter number 2, chapter 2, which is the Newton's second law of motion, F equals to ma. Now we in chapter 2 we were looking at the force that has caused the object to move, to accelerate. So by using the equation F equals to ma. So for the chapter number 3, the third chapter, we are still in particle kinetics, where we are talking about the force, but now we are looking into another method to calculate the force acting on a moving particle, that is using the work and energy method. So the chapter, the name of the chapter is work and energy, but for today's lesson we are looking into work and kinetic energy. Okay. Let's look at the lesson outcomes for today's class. At the end of this lesson, you should be able to understand about kinetic energy of a particle in motion. Okay, I think most of you should already aware what kinetic energy is. And then you should be able to understand which force is doing work and which force is not doing work throughout the motion. So we're going to be looking into a motion of particle moving from, let's say, position number 1 to position number 2. So particle ini bergerak dari nombor 1 ke nombor 2, position pertama sehingga position yang terakhir. And throughout the motion ini kita akan tengok force mana yang melakukan kerja, is doing work done, dan force mana yang tidak melakukan kerja, is not doing work throughout the motion. And then we're gonna calculate the work of various external forces acting on a particle throughout the motion. So these are the outcomes for today's lesson. Before we continue, let's look at the overview of this whole chapter. So tadi I told you about chapter 1 where we discuss about kinematics, particle kinematics, and then another branch of dynamics is kinetics, where we discuss about the force. And as I have mentioned, chapter 2 we were discussing about force and acceleration, F equals to ma. This is the Newton's second law of motion. So for chapter 3 we are here, work and energy, and as you can see here, the yellow colored boxes here are the sub-chapters of chapter 3. So today we are going to cover the first two sub-chapter, which is kinetic energy and the work. On Wednesday we are going into principle of work and energy, and next week we will be finishing this chapter with power and efficiency, and finally the conservation of energy. So hopefully by next week we are going to finish with this chapter. Okay, let's talk about kinetic energy. Okay, I hope all of you are aware that kinetic energy is the energy an object has because of its motion. Okay, kalau objek itu static, dia tidak bergerak, so there will be no kinetic energy. But when an object, a particle, is moving, is in motion, then it will have kinetic energy. Okay, if we want to accelerate an object, we must apply a force. Okay, this is the Newton's second law of motion, F equals to ma. Kalau kita nak bagi acceleration kepada object tersebut, kepada particle, we need to apply force F so that it will accelerate. Therefore the equation F equals to ma. Applying a force requires us to do work. Okay, after work has been done, energy has been transferred to the object. The object will be moving with a new constant speed. Okay, this is a little bit of explanation about kinetic energy. Okay, the energy transferred is known as kinetic energy. It depends on the mass and speed achieved by the object. So anybody here knows what is the formula to calculate the kinetic energy of a particle, of an object? Siapa tahu? Siapa boleh ingat daripada physics dulu? What is the formula to calculate kinetic energy? Anyone remember the formula?
One over 2 mv squared.
1 over 2 mv squared. Thank you, Wan Lukman. Very good. So, kinetic energy in dynamics, we will call it as T. Okay, T here means kinetic energy. T dalam simbol T dalam dynamics, kita merujuk kepada kinetic energy. So, the formula to calculate T, kinetic energy, is 1 over 2 mv squared. Okay. So, if you look at this formula here, half times mass of a particle, mass of an object will always be positive. Tak akan ada berat sesuatu benda yang negatif. Berat mesti positif. And then we have velocity. Velocity boleh jadi positif, boleh jadi negatif, because velocity is a vector which has direction. Okay, so direction ini bergantung kepada the axis. If the direction of velocity is in the positive direction of the axis, then velocity will be positive. Kalau velocity is in the opposite direction, velocity will be negative. But in this formula, you will see that v is squared. So kalau v ini negatif sekalipun, selepas dia di squarekan, di kuasa duakan, it will be positive also. So which means that kinetic energy, you have to remember that kinetic energy is always positive. Okay, there will never be a kinetic energy that is negative. Kinetic energy is always positive. What is the unit for kinetic energy? unit for all energy, any type of energy is joule. Okay, so the unit for kinetic energy is joule ataupun kita tulis sebagai capital J. Okay, joule. Kinetic energy is always positive regardless of the direction of motion of particle. Okay, seperti yang saya mention tadi, kalaupun particle itu bergerak dalam negative direction of the axis, the kinetic energy is also positive because kita squarekan the velocity. Okay, that is all about kinetic energy. So simple saja, kinetic energy, what you have to remember is the kinetic energy T is equal to 1/2 mv square. Okay, alright, let's look at work done of a constant force. Okay, work done ni bergantung kepada jenis force. So now we are talking about a constant force. What is work done by a force? Okay, the definition of work done is a force F will do work on a particle only when the particle undergoes displacement in the direction of the force. What do you understand from this sentence here? Apa yang you faham selepas membaca ayat ni? Force akan melakukan work, akan buat kerja apabila displacement apabila the particle mengalami displacement dalam arah yang sama dengan arah force, arah daya yang diberi. Okay, displacement of the particle must be in the same direction of the force, then only the force will do work. Ada siapa-siapa yang tak faham tak membaca ayat ni? Boleh faham?
Boleh saya.
Okay, tak apa. Let's look at this green box here. Katakan kita abaikan friction. There is no friction. So what are the forces yang currently acting on this box? Can you tell me? We will have the weight, kan? Betul tak? Definitely there will be a weight mg pointing down. And then the box is in contact with the ground. So apa yang ada bila in contact with ground? Force apa yang akan ada?
Normal force.
Normal force. Okay, so kita akan ada normal force NA point ke atas di arah bertentangan dengan weight. Okay, katakan juga pada masa ini kita apply satu force F pada sebelah kiri box ini. Okay, pada sebelah kiri box ni, dari pandangan saya sebelah kiri lah. Okay, kita apply pada satu sisi box ini force F. So kesemua sekali ada 3 force yang bertindak kepada kotak hijau ini. So because of the force F pushing the box will move to a second position. Okay, for example, so this is, let's say this is the first position initially. This is the first position. Then apabila kita apply force F, the box now move to a new position. Okay. The question here is, which forces are doing work? Daripada 3 force yang ada ini, force mana yang melakukan kerja? Anybody can tell me which force are doing work in this case?
F.
F, okay. Lagi? mg ada buat kerja tak?
Tak ada.
What about NA?
Tak ada.
Pun tak ada. Yang lain agree dengan Faris? Do you agree?
Yes.
Yeah, okay. Let's look at jawapan Faris tu betul ke tak based on kita punya ayat di atas ni. Force F will do work only when particle undergoes displacement in the direction of force. Okay. Kita tengok force F dulu. Okay, kita tengok force F dulu. Force F ini bertindak ke kanan. So, kalau you tengok displacement pergerakan kotak ni, adakah kotak ini bergerak dalam arah yang sama dengan force F tadi? Kotak ni bergerak sama tak? Sama arah dengan force tak?
Sama.
Sama kan? Okay, so force F bertindak ke kanan, kotak pun bergerak ke kanan. Okay, so daripada definition di atas ini, definitely force F is doing work. Okay, now let's look at mg. Mg bertindak ke bawah. force F ini, kotak ini, adakah dia bergerak di arah yang sama dengan mg? Saya ulang, mg bertindak ke bawah, kotak bergerak ke kanan. Jadi adakah mg ini melakukan work ataupun tidak based on the definition here?
Tak.
Okay, so mg dan na tidak melakukan work. There are no work done by mg and na because the box is not moving in this direction, in y direction. Box hanya move in x direction, in the same direction as force F. Therefore, only force F is doing work. Okay, and then you can see there is displacement of the box from position 1 to position 2, ada change of position, delta S. Therefore, work done by force F is kita tulis sebagai U. Okay, work done kita gunakan simbol U. So kalau sekarang ni kita bercakap tentang force F, so kita boleh tulis sebagai UF. Okay, UF is equal to the force itself F multiply with delta S. Okay, delta S ni dalam unit meter lah. Delta S dalam unit meter, F ini dalam unit Newton. Okay, and the unit for work is also joule, sama macam energy tadi. Alright, so mg and na, no work done. In this case, only F is doing work. And how to calculate work done by the force F is by multiplying the force with the displacement, delta S. Alright, ada apa-apa soalan setakat ni? Setakat ini ada apa-apa soalan? Okay, saya harap clear. Alright. Ini work done by of a constant force. Kalau force itu kekal daripada position pertama sehingga position kedua, the amount of force applied is the same. What if the work done, what if the force applied is a variable force? Maksudnya, force yang di-apply itu tidak sama, berubah-ubah mengikut tempat. Okay, so let's look at this example. A particle here moving from position 1 ataupun S1 moving to position number 2 S2, dan force applied here F is changing with respect to the position of the particle. Okay, macam ni. S1 force dia mungkin berada di sini dan S2 force dia semakin naik. Okay, if F varies with respect to S, F ni berubah mengikut displacement, mengikut position S, then UF 1 to 2, UF 1 to 2 maksud dia pergerakan daripada position 1 ke position 2, we need to do some integration. Okay, integration daripada S1 hingga ke S2, F cos theta ds. Okay, F cos theta ni yang color pink ni, color magenta ni, F cos theta ds. This is how you calculate work done by a variable force. Kalau force tu vary berdasarkan position of the particle. Okay. Tapi ada satu soalan dekat sini, why we only consider F cos theta? What about F sin theta? Why F sin theta is not considered? Ada siapa-siapa boleh jawab? Why do you think F sin theta is not considered dalam calculation of force ni? Anyone?
Sebab displacement bergerak dalam keadaan horizontal, S axis.
Betul. Bukan X axis, tapi this is a tangential axis lah. Okay, tangential axis. So kalau kita resolve dalam satu lagi arah, F sin theta will be pointing up. So pada sepanjang masa, partikel ini tidak bergerak ke atas bawah, dia hanya bergerak ke kiri kanan saja, ke kanan. So in the direction of f cos theta. So that's why we don't have to consider f sin theta, because this component of force f sin theta is not doing work. Komponen yang melakukan kerja, yang buat work, hanyalah f cos theta. Okay? Alright. Ada apa-apa soalan untuk variable force? Okay, I assume that it is clear. Now, let's look at work of a weight. Okay. Sebelum ini kita katakan dalam kes yang pertama tadi, bila kotak ini bergerak ke kanan sahaja, weight tidak melakukan kerja. The weight is not doing any work. But what if the box is now going down? Okay, the box is going down purely based on due to the weight. Maksudnya dia macam free fall lah. Kita just release the box from a certain height. Because of the weight, the box is going down. So in this case, we can get the height of the change of position of the box with respect to y-axis, ataupun kita tulis sebagai delta y, change of height. Okay, change of height of the box. So when there is change of height delta y, then we can calculate work done by weight UW is equal to negative W times delta Y. Okay, minus W times delta Y. W dekat sini ni is equal to mg lah. Ataupun you boleh tulis juga sebagai minus mg times delta Y. Okay, kalau partikel ini bergerak ke bawah, which means that delta y will be negative. Remember, kita punya positive y-axis is pointing up. So, kalau partikel ini bergerak ke bawah, delta y akan jadi negative. Okay, you imagine delta y in this equation will be negative. So, akan ada dua negative sign, which then will be UW will be positive. Disebabkan ada dua negative sign. If the particle move upwards, kalau partikel tu bergerak ke atas, delta y akan jadi positif. So then you will have one negative sign, one positive sign, which in the end will be UW will be negative. Okay, you faham tak maksud dia? Kalau partikel ataupun objek itu bergerak ke bawah, work done by weight is positive. Kalau partikel itu bergerak ke atas, work done by weight akan jadi negatif. Kenapa macam ni? Because the gravitational acceleration G is always pointing down. So kalau objek tu bergerak sama arah dengan gravitational acceleration, dengan gravity, work done by weight akan jadi positif lah, sama arah dengan gravity. Tapi kalau kita baling kotak tu ke atas, partikel ataupun objek itu bergerak ke atas, dia ialah di arah bertentangan dengan gravity. So that's why work done by weight will be negative. Okay? Jelas tak ini? Ada apa-apa soalan? Work of a weight? Any question? Okay. If there is no question, let's look at another type of work done. Okay. Satu lagi jenis work done is work of a spring force. Okay. Di mana dalam case kita ada the object ataupun the particle is connected to a spring. Okay. So dalam case yang spring ini unstretched ataupun spring ini dalam natural position, maksudnya dia tidak di-compress, dia tidak di-stretch. Inilah natural position spring ataupun inilah panjang sebenar spring tersebut. If the spring is unstretched, then the force of spring equals to zero lah. Tak ada spring force. Kalau dia unstretched, tak ada spring force. Okay. If now the spring is compressed, okay, the spring is compressed, dan kita tahu jarak compression from the unstretched punya, from the natural position of the spring is S1, then the spring force now becomes negative KS1. Ini spring force, belum work done lagi ni. Ni baru cerita pasal spring force. Negative KS1. Ada negative sign kat sini. K ni apa? K is the spring constant. Okay, spring constant, which is always given in the problem, where the unit of spring constant is Newton per meter. Okay, Newton per meter. That is the unit for spring constant K. This is the case of compression. Kalau the spring is stretched, okay, daripada panjang asal dia yang merah ni, dia stretch ke sini. So akan ada elongation of the spring ataupun pemanjangan spring sebanyak S2 ni, S2. So dalam case of stretch, the spring force is then minus K times S2. Okay? Okay. Many student make mistake. Okay, sebelum saya pergi ke situ, the work done by the spring, how to calculate work done by a spring, it is given by this formula. Minus 1 over 2 times K. Tadi saya dah bagi tahu K is the spring constant. So minus half times spring constant, multiply with S2 square minus S1 square. S2 minus S1 ni ialah spring tadi, katakan dia daripada position pertama, dan partikel tersebut kita tarik spring tu ke position yang kedua. So daripada position pertama ke position kedua itu, what is S1 pada position pertama and what is S2 pada position kedua, that you have to find out lah. So kalaulah daripada spring tu asalnya daripada dia unstretched, daripada dia natural position, S1 dia ialah natural position, therefore S1 equals to 0 lah. Kalau natural position, S1 equals to 0. And then the spring, let's say, is compressed. So S2 now becomes yang ni, the compression punya length. Okay. And kalau dia stretch, dia akan jadi the elongation. Okay, the elongation. So position number 2 ni depends on the situation lah, whether the spring is being compressed atau the spring is being stretched. Alright. So this is the formula. Unit is also joule, unit of work done by a spring. Many students make mistakes that you find the length of the spring. This is not S1. The length of spring after being compressed is not S1. Okay, this is the compressed length of the spring. Yang atas ini ialah the panjang spring pada natural position, unstretched. So how to find S1 ni is basically the unstretched length of spring, natural length of the spring minus the compressed length of the spring. Yang kita nak cari S1 ni ialah yang depan ini, bukan yang bahagian spring ini. Okay, so please bear in mind about this. This is not S1. S1 ialah bahagian depan ni, bukannya panjang spring. Same goes for the case of stretch di bawah ini. This is the stretch length of the spring, not S2. This is not S2 ataupun S1. Okay, so how to find S2 is basically the stretch length of the spring minus the length of the natural length of the spring ataupun unstretched length of the spring. Okay, so that is all the work of a spring force. Do you have any question before we look at a few example? Do you have any question? Anyone? Ada apa-apa soalan? Okay, so before we do some example calculation, let's recap about what we have covered. So work done, first we look at work done of a constant force. Okay, so work done ini hanya berlaku apabila force ini apabila the object, the work done of a force is when the object is undergoing displacement in the same direction as the force. Okay, so in this case, UF is equal to the force itself multiplied with the displacement delta S. Okay, and then if the force is a variable force, then we need to do some integration. Okay, F cos theta ds from S1 to S2. F sin theta is not considered because there is no work done by the F sin theta. And then there is work of a weight. Okay, apabila partikel ataupun objek itu mengalami perubahan height, ataupun dia turun ke bawah ataupun dia naik ke atas, then there is work done by the weight, which can be calculated using this formula. UW is minus W times delta theta. Okay, and then finally we talk about work of a spring, force, which can be calculated by this formula. US is equal to minus 1 over 2 K times S2 square minus S1 square. Okay, so if you don't have any question, I would like to okay. So this is the first example. Let's read the example. The 20 kg crate is subjected to a force having a constant direction and a magnitude of 100 newtons. So we know that F here is equal to 100 newton. Okay, starting from S1 equals to 15 meter. Okay, S1 equals to 15 meter. The crate is moving to the right until S2 equals to 25. Maksudnya S1 ni katakan we have S1 over here. Okay, this is already 15 meter, and then it is moving to the right to S2, which is 25 meter. S1 is equals to 15 meter. Okay, the coefficient of kinetic friction between the crate and the ground is mu k 0.25. Determine the total work done. So what we want to find is the total work done, keseluruhannya. Okay, so to know the total work done, first we need to identify what are the forces acting on this crate. Okay, can you tell me what are the forces that is currently acting on the crate? We definitely will have a weight pointing down. This will be mg. Alright, and let's force apa? We have this force F here, of course. Force F yang pulling force ini. Okay, this force F. That's number 2. Apa lagi force yang lain? Correct, normal and friction. So I'm gonna erase this first because I want to draw the normal force. Normal force will be acting somewhere here. Okay, this will be, let's call this NP, and then we're gonna have friction force, which is in the opposite direction of the motion. So this will be F arah friction. Okay, so altogether we have 4 forces that is currently acting on the crate. So in fact, the force 100 newton ini we can also okay, let's define our coordinate system dulu lah. So let's define x positive to the right and y positive pointing up. And this force F here we can also resolve into 2 components based on our axis. So this will be Fy and this will be Fx. Okay, so Fy, or we can straight away write it as 100 cos 30 degrees is Fx, and Fy we can write it as 100 sine 30 degrees. Okay, S1 here, that is equal to 15 meter. So basically our delta S, if we draw delta S, is equal to what is our delta S? S1 starts from 15, S2 is 25. So actually delta S kita sebenarnya berapa? 10 meter, right? Delta S kita ialah 10 meter. Alright. So we have all the information here. First we need to identify which one is doing work, which one is not doing work. MG is it doing work or not? MG is not doing work. Okay, so MG is not doing any work because the crate is not moving up and down. So same goes for NA. NA is not doing work as well because the motion is only in the x-axis. So therefore, this 100 sine 30, the component of the y component of force F is also not doing work. So the forces that is doing work is only the friction. Okay, we have the friction here. We have the x component of 100 newton force, that is 100 cos 30. So only two forces are doing work, and the other three forces are not doing work in this case. Okay, so let's look at the 100 cos 30 first. 100 cos 30. So how do we calculate this? F, I'm going to write this as is U F X. Let's call it as U F X. Okay. How do we calculate the work done by force in x-axis 100 cos 30? So based on our formula before, the work done by force is constant force is the force multiplied with delta S. Okay, so the force here you have 100 cos 30 degrees multiplied with delta S is 10 meter. Okay, so basically we have UFX is equal to, you let me calculate. I don't have my calculator. But once I calculate, what do you have? 100 cos 30, 866.03. Okay, 866.1 joule. Okay, ini one force, sorry, one work. We have another work done by friction, UFR, by friction. Okay, but we need to know what is the friction force. The FR here, FR is equal to mu K times NA, right? FR is mu K times NA. So first we need to know what is NA because mu K is given. So how do we get NA? How do we get the value of NA? Do you have any idea? Sorry? Alright. So sometimes also we are in chapter 3, you need to use the knowledge from chapter 2. So basically now we need to what do you call resolve in we need to calculate the force in y-axis. So y-axis is positive upwards. Sum of Fy is equal to 0. Sorry. Okay, sum of Fy equals to 0 because there is no motion in y-axis. So Ay equals to 0. So in this case, we have NA plus we have the force, the component of F 100 sine 30 degrees, and we have minus mg is equal to 0. So from this, you can get what is the value of NA. Okay, what is the value of NA here? Mg minus 100 sine 30. Let me get my calculator for a while. Ada yang dah calculate? What do you have? Mg is 20 times 9.81 minus 100 sine 30. You get 146.2. So Na is 146.2 Newton. Therefore, friction force is 146.2 times 0.25, which is equal to 36.55 Newton. This is the friction force. So going back to our work done, UFR, U friction, is the force friction Fr times delta S. Okay, but in this case, friction is moving in the opposite direction of delta S, so it will be negative lah. Okay, it will be negative. The force, I think delta S, it should be negative. The force is 36.55 multiply with negative 10 in this case. Okay, so what you have is minus 365.5 joule. Okay, so this is the work done by the friction force. So the total work done is then we can write it as total of U1 to 2, which means that the total work done to move from position 1 to position number 2 is, then you will sum up all the work done here lah. So it will be equal to 866.1 minus 365.5. So which will be equal to 866.1 minus 365.5. You have 500.6. So this is 500.6 joule. So this will be the final answer of the work done by the total work done to move the crate from position 1 to position 2. This is the total work done to do this. So it's 500.6 joule. All right. Any question? Do you have any question on this?
For these questions, can we get the Fx, then we minus the frictional force first, then we multiply with the displacement that the object travel?
Good question. I haven't tried that, but let's try. So what you are asking is that we do 100 cos 30 minus 36.55, right? Yeah,
Yes.
you will get the same answer. So I think you can do that also, which means that you find the force in x-axis, so you balance out the force, the force to the right, which is 100 cos 30 minus the friction force first, and then you multiply with the displacement. You will also get the same answer.
Okay, thank you, sir.
All right. Okay, any more question? Okay, let's look at another example. Okay, this is example number 2. The motor exerts a constant force, 300 Newton on the cable. Okay, so let's draw that. There will be a 300 Newton pulling force, 300 Newton. Let's call this F. Okay, travels 10 meter up the plane. The 20 kg crate travels 10 meter up the plane starting from rest. Okay, so we straight away draw the free body diagram. So there will be a weight pointing down here. This will be mg, and then this box is in contact with the ground, so there will be normal force Na. All right, and it says something about friction, so there must be friction as well going in the opposite direction. So this will be Fr. Okay, determine the total work done. Okay, let's first determine which force is doing work, which one is not doing work. Which one is not doing work in this case?
NA, normal force.
NA is not doing work. Okay, so this is not doing any work, NA. What about the weight mg? Mg ada buat work tak?
NG sin theta tak?
Mg sin theta. Tapi okay, remember mg dia tak sama macam force yang lain. Mg kalau ada perubahan height, if there is a change of height, then mg will do work. So sekarang ni the question is, ada perubahan tinggi tak? Ada perubahan height tak? By the box, experience by the box, ada tak perubahan height?
Ada.
Ada. Okay, so which means that mg must be doing work lah, because there is a change of height. Okay, let's look at how can we solve this. All right. Let's start with the force. Okay, if we want to calculate the friction, let's find out what is NA first lah. So we need to define our axis slightly in this direction, so that it will be easier for us to calculate. This will be our positive x-axis, this will be our positive y-axis. Okay, now let's look at in y-axis. Going back to chapter 2, total force in y-axis is equal to 0, because the box is not moving in y-axis, it is only traveling in x-axis. So what we have in y-axis is NA, and then we have minus mg cos 30 degrees, right? This will be 30 degrees here. This is 30 degrees, so it must be NA minus mg cos 30 degrees is equal to 0. So we have NA, therefore NA is equal to mg cos 30 degrees. So m is 20 times 9.81 times cos of 30 degrees. We have 169.9. 169.9 Newton. This is our normal force. Okay, from here we can calculate the friction. So Fr is 169.9 times 0.3, the mu k. So FR is equals to 50.97. Okay, 50.97 Newton. Okay, so we can use the method suggested by our friends just now, just balancing out force in x-axis. So force in x, F, let's call this as Fx, is equal to 300 Newton positive in x-axis minus the friction, which is 50.97. So you get Fx is 249. Okay, 249.03. Okay, 249.03 Newton. Okay, so it says here travels 10 meter up the plane. So we know that delta S is equals to 10 meter. Okay, so then we can calculate ufx is equal to 249.03 times 10 meter times delta S, which is 2490.3 joule. Okay, that is the work done by the force in x-axis. Now let's look at as I've said earlier, the component of weight here, mg, since there is change of height, then mg must be doing work. Okay, mg must be doing work. So let's write the formula first from our slides just now. uw is minus w times delta y. Okay, minus w kita tahu, minus w is mg lah, w is equal to mg. But the question now is, what is our delta y? What is our delta y here? Okay, now let's imagine that the box has traveled to this location. This is the new location of the box. Okay, so if I draw a line from here, okay, I hope you can see the line. If I draw the line from here, then delta y, this will be the center of the box over here. So delta y ni ke mana? From this line to this will be our delta y. This, saya tebalkan sikit takut tak nampak. So this will be our delta y going up. Delta y is going up. Can you see this? Sorry. Okay, boleh nampak tak? Semua boleh nampak?
Boleh, sir.
Boleh. Okay, so delta y is the change of height. So you boleh nampak yang the box is apa ni, experience change of height lah. The center of gravity of the box yang saya warnakan dengan biru ni, tengah-tengah ni, center of gravity, this is this blue to this blue. Okay, so dia ada perubahan. Dia tak ikut axis yang sengit tu tau bila weight, because weight is always acting downwards. Okay, so walaupun kita pakai axis kita define y dan x tu sengit 30 degrees mengikut kita punya plane, tapi to calculate the work done by the force, we don't consider that axis. We must consider only the change of height in vertical line. Okay, in vertical change of height, vertical height. So what we are interested in is this delta y here, this delta y. So how do we find that delta y? we need that delta y to calculate kita punya work done by the weight. Work done by the weight is UW, is minus W times delta y, this one. Okay, so how do we get delta y? Any idea?
F sin theta.
Which one sin theta? Apa sin theta? Can you repeat please?
F sin theta.
Betul, thank you Wan Lukman. S sin theta. Okay, so kita ada S kita sekarang ni given dekat sini. S ialah 10 meter. So delta y is equal to S times sin theta, or ataupun we can substitute the value to be 10 times sin 30 degrees. Okay, because dekat sini sebenarnya you can draw 30 degrees is over here. This is 30 degrees angle. Okay, over there is 30 degrees angle. So we have this angle here. Saya buat dia tebal sikit dekat sini, sorry. This line here is basically 10 meter. This is the hypotenuse. Okay, this is 10 meter. Yang black color tu 10 meter. So we have, you boleh nampak dia sebagai satu triangle lah. So what we want is this side over here, delta y, which can be calculated using 10 sin 30 degrees. Okay, so 10 sin 30 degrees dapat berapa? 5. So you get here, delta y is equal to 5. Okay, then we substitute in this equation lah. Substitute in this equation. Substitute in this equation. UW is equal to minus mg minus 20 times 9.81, and then is delta y. So delta y ini 5 or minus 5? Mana satu? Tadi saya dah bagi tahu kalau 5 positive. Positive, correct. Because the box is now moving up. So kalau dia move up, delta y will be positive, which then UW will become negative. Kalau dia turun bawah, dia akan jadi negative delta y. So UW akan jadi positive. So in this case, we put in delta y as 5. So therefore, kita akan dapat UW equals to minus 20 times 9.81 times 5 is minus 981. Okay, minus 981. Alright, so altogether we can then write the sum of work done to move from 1 to 2 is equal to, we have the UFX up there, 2490.3 minus 981. So we have, this is equal to 2490.3 minus 981 is, 2490.3 minus 981, 1509.3 joule. Okay, so this is the total work done to move the box from bottom going up 10 meter. Okay. Any question? Is this clear? Any question? Okay. Kalau tak ada soalan, let's continue with the next one. Okay, let's continue with the next example. The spring. Now we have a spring. The spring is placed between the wall and 10 kg block. The block is subjected to a force F, 500 Newton. And the block travels to S equals to 0.5. Okay. S di sini is equal to 0.5 meter. Okay. When S equals to 0, the block is at rest, the spring is uncompressed. Okay, this information is very important. Dia cakap when S equals to 0, spring uncompressed. The contact surface is smooth. Okay, contact surface is smooth di sini. Apa maksud dia smooth kat sini? Smooth means no friction. Okay, kalau dia kata the surface is smooth, maksud dia no friction. So we don't have to consider friction lah. Determine the total work done. Okay, let's draw the free body diagram first. Right, so definitely we're going to have weight. Okay, this is mg. And then we have the NA. And then we have this 500 Newton force. Okay, 500 Newton force here, which we can resolve into two components. Alright, we can resolve into two components. So this will be 500 times apa kat sini? 4/5, right? 4/5. Do you know how to use this small triangle here? Ada tak yang tak tahu macam mana nak guna? Do you want me to explain how to use that small triangle? Ataupun you dah tahu dah?
Sir,
Ya?
ada masalah internet, sir.
Masalah internet?
Internet dekat UMP tiba-tiba tak ada.
Oh, semua orang tak ada lah ni?
Saya tak pastilah yang lain tu.
I see, okay. Tak apalah, yang mana ada, because I am recording this session. So nanti saya akan upload yang ada problem internet, you can watch later lah. Boleh? How many of you ada dekat UMP? Tak tahu?
Rasanya kebanyakan lah.
Yeah, okay. Tak apa, let's just continue dengan siapa yang ada di sini. So if you want me to explain this, let's just quickly explain how to use this small triangle here. Bila dia bagi small triangle di sini, you can imagine that if down here is theta, this angle is theta. Okay, so if this angle is theta, which means that this here is also theta, angle here also theta. So the component, the horizontal component here must be 500. This component is then 500 sine theta. Okay, and then how do you get the sine? How do you get the sine is from this triangle, sine is equivalent to the opposite over hypotenuse. Okay, opposite over hypotenuse, that's why you get 4/5 for this part. And for this component, this will be 500 cos theta. Okay, this part here. So cos theta will be the adjacent over hypotenuse, or 3/5. Right, so here you will have 500 times 3/5. Okay, that is how you use the small triangle given tu lah. Okay. Alright, so let's determine which one is not doing work. So mg is not doing work, the normal force is not doing work, as well as the y component of the 500 Newton force is also not doing work. So we only have one force is doing work, as well as the spring. The spring kita tengok later. Let's calculate UF first. Okay, UF is 500, the force itself, so 500 times 4 over 5 multiply with delta S. So here it says that delta S is 0.5 meter, travels 0.5 meters, so this will be multiplied with 0.5 lah. So you will have UF is 500 times 4 over 5 times 0.5 is 200 joule. So this will be 200 joule UF. Okay. And then we have the work done by the spring. Okay. So if we recall the formula, work done by the spring, US is minus 1 over 2 times K times S2 square minus S1 square. Okay. Now K is given here. K is given here 500 Newton meter. So what we need to determine is what is the value of S2 and what is the value of S1. If you are able to get these two values, S2 and S1, then you will be able to solve or to calculate what is the work done by spring lah. Okay, let's look at S1 first. Do you know what is the value of S1? Just by looking at the question.
0.
0, okay? Because it says when S equals to 0 ataupun initially, when S equals to 0, initial position, the spring is uncompressed. Spring is uncompressed means that initially there is no compression lah. It is the spring is at its natural state ataupun unstretched length. So S1 equals to 0. Now S2, what will be the value of S2? What will be the value of S2? Any idea? What is the value of S2? If the box now travels to here, if the box now travels to here, okay, and causes the spring to be compressed like this, what will be S2?
Negative 0.5.
Dia bukan negatif, dia positif je value dia. So you are correct, because the box is travelling 0.5 to the right, which means that it will compress the spring of 0.5 also lah. Maksudnya the compression length tu is also 0.5 because dia sama dengan dia punya distance travel of the box of the block to the right. So S2 is basically 0.5 in this case. So then you can substitute in the equation 1 over 2 times K is given as 500 times 0.5 square minus 0. Okay. So from here we can get minus half times 500 times 0.5 square minus 62.5. So minus 62.5 joule. Okay, that is the work done by the spring. So in the end, we can calculate the total work done to move the spring from position 1 to position 2 is equal to 200 minus 62.5, which is equal to 137.5 joule. Okay, so this will be the final answer. All right. Any question on this? If there is no more question, I think we will end the class for today. this will be the end of the class lah. If you don't have any question, do you have any question? No question?
No, sir.
Okay. So never mind for the rest yang ada di UMP yang mana ada problem dengan internet, I will upload this recording video to YouTube so that you can watch later lah. Okay. So thank you for coming to the class. Before we go, let me get a screenshot of the attendance. Okay. So that's all for today's class. Today we have covered let's go back to the summary of what we have learned today. So today we have learned about kinetic energy of a moving particle. Okay, kinetic energy is given by T is 1/2 mv square. Okay, kinetic energy is always going to be positive because v square. Okay. And then we learn about work of a constant force. UF is equal to F times delta S. If there is a variable force, then you have to do some integration. Integrate of S1 to S2, F cos theta ds. Work done by weight. UW is minus W times delta Y. Okay, depending on whether the particle is going down or going up. Delta Y will be negative or positive based on the situation. And finally, we learn about spring force, work done by spring force, which is US is equal to minus 1/2 K times S2 square minus S1 square. And finally, we did some calculation of total work done to move from one position to another. Okay, so that will be the end of today's class. In the next class, on Wednesday, we will cover the principle of work and energy. Okay, this will be the subchapter that we will going to cover on Wednesday. Alright, so if you don't have any question, I would like to thank you for joining the class today. I will see you again on Wednesday. Assalamualaikum and have a good day.